Good morning, good afternoon, good evening. The topic of today's lecture is to turn our attention to how to analyze which inputs to use in production. If you remember back to the circular flow, you had the firm and it was choosing its inputs. And we noted that's a choice that they make about how to produce the good. What inputs would I in fact use? So what we're looking at today is to evaluate the characteristics of different inputs, different resources, and then see how by reorganizing the inputs being used, recognizing opportunity cost, economic opportunity cost, it's possible to increase output without any additional effort, just by reorganizing production according to what we'll call comparative advantage. It's possible to get more production. We'll then look at the gains from trade between nations and talk about how nations choose to specialize in producing particular goods, and in doing that, increase the gains from trade to both parties. So first of all, our assumption is that resources differ in their absolute and relative ability to produce goods. When we talk about absolute ability, we're talking about per time period, like a harvest season. And just think about different plots of land. Well, they clearly would have different fertility rates, you know, with me, different degrees of soil content that would grow various plants. You all have tremendously different skills as resources. Some of you type really fast. Some of you don't type at all. Some of you are really good at analytical database work. But we all differ in our relative skills and our relative abilities. So the assumption is, as I said, number one, some inputs are simply more productive per time period than other inputs. And that is called absolute advantage. Y'all with me? Absolute means per time period. So an absolute advantage would mean you can type 20 papers in a day and I can only type 15. So in terms of output per time period, you have an absolute advantage. Everybody with me? That's absolute advantage. Good. Now, it's also true if we compare the relative ability to produce different goods, that those ratios will not be the same for all the people involved. You may be really good at typing and not very good at data sets. You might be really good at data sets, not very good at typing. Everybody with me? So it's not only do we differ in our absolute abilities, but we also differ in our relative abilities. And that's going to be the basis of what we call comparative advantage. Comparative advantage refers to relative abilities across goods. So I want to look at two possible resources, Crusoe and Friday. Very simple example on an island. And I want to look at two possible outputs, and that is fish and coconuts. So each resource can produce fish or coconuts, and they're two different resources we'll be comparing. Once you have two products, that is sufficient to represent the relationship between end products, like 20 or 50 or 100 products. As long as you have two in the analysis, the conclusions are applicable to whether you had 2 or 20 or a whole lot more. The same thing is true of how many resources you're looking at. If we have two resources, in this case Crusoe and Friday, I have a sufficient number to generate analysis for any number of people, So this is their production possibilities. This is what they're able to produce in a 1 8-hour day. They start out at opposite ends of the island, so they don't know each other. Crusoe, if he spends the entire day fishing, can get 8 fish. If he spends the entire day gathering coconuts, he can also get 8 coconuts. Or if he splits his time up, he could get any linear combination of those. It's obvious that it's 1 per hour, right? Whether it's coconuts or fish. So he could do 0 coconuts and 8 fish. Or he could get 1 coconut, that would be an hour gone, and get 7 fish, or 2 coconuts and 6 fish, and on, down 4 and 4, and so forth. So that's his abilities. That's what his relative abilities are. Friday, different resource. He's more productive in either one of the two goods. Everybody see it? In fish, he can do 10. Crusoe can only do 8. Coconuts, 20 versus 8. So Friday has an absolute advantage in both products. He's more productive per time period than the other resource. If you want to generate this to thinking about international trade, think of Friday as being the United States, and think of Crusoe as being Bangladesh or Indonesia or India or any of the developing countries. The United States has an absolute advantage in producing almost everything. We're simply more productive per time period. The reason is that we have a much higher educational standard in the United States. K through 12 is paid for everybody, free, some quality of it. And then we have an extensive junior college in California, junior college and college system. In fact, the college system, as you know, is split. We have Cal State universities, which focus on teaching, and then we have the University of California system, which is UCLA and Berkeley and those schools, UC San Diego. And those are larger schools and more focused on research. And so the classes there are much, much larger than the classes here, like 500 students in the introductory class. Good. So the United States is more educated, and that leads to being more productive. And also, the United States has a much higher capital stock than many, many developing nations. Capital stock, remember, refers to buildings, equipment, chairs, software, computers, all the things that you use. So American workers being able to access that more advanced equipment also become more productive as a result of that. So the U.S., as I said, has an absolute advantage in almost every product. Now, Friday has different relative ability also. If you look at Crusoe, his trade-off was 1 for 1. 8 fish or 8 coconuts. So every time he gathers a fish, he gives up a coconut. Every time he gathers a coconut, he gives up a fish, opportunity cost. Friday has 10 to 20. So every one of his fish that he gets cost him what? 2 coconuts, right? And every coconut that he gathers cost him a half of a fish. So he has different relative abilities, 1 to 1 versus 1 to 2 or 2 to 1. So that represents that the second assumption, that resources differ in their relative ability to produce goods. So notice Friday's more productive. That's like the United States. He has an absolute advantage, and then the United States does too. Now here's what we want to do, thinking like economists. We know, applying economic thinking, that the cost to Crusoe of gathering a fish is what he could have done with the time. Everybody with me? It's opportunity cost. The cost to him of that fish is what he could have done in coconuts, and it is 1 coconut. And by the way you solve this equation, which you all should know, if I have 8 fish equals 8 coconuts and I want to get 1 fish, divide both sides by 8 and then I get the answer. Everybody see it? Divide by the coefficient of whatever it is you're trying to solve for, and then you'll end up with a 1-to-1 ratio. So divide both by 8 and you get 1 fish equals 1 coconut, meaning cost, and 1 coconut cost him 1 fish. Friday has a 10 to 20 ratio. If I wanted to solve for 1 fish, I would divide both sides by what? By 10. By 10, because that's the coefficient of fish. And I would get 1 fish equals 2 coconuts, or 1 coconut equals 1/2 of a fish. So Crusoe has a comparative advantage in fishing. His cost is only 1 coconut. Friday's cost is 2 coconuts. And then if we turn our attention to gathering coconuts, we notice that Friday has a comparative advantage because his ratio is 1 to 1/2, whereas Crusoe's is 1 to 1. The cost to Friday of gathering a coconut is a half a fish because his relative ability is 1 fish for 2 coconuts. Now this is very important because it turns out, as we try to think about comparative advantage, as long as they don't have the identical ratio, and our assumption is they don't, right? If Crusoe has a comparative advantage in fish, automatically Friday has a comparative advantage in coconuts. Y'all with me? It's just math, right? It's just math. You're solving the same relationship in each case, trying to solve for one unit. But that's very significant because as we think about the United States and Indonesia, if we have a comparative advantage in producing television sets relative to carved statuary, then automatically Indonesia has a comparative advantage in carved statuary versus the United States. That has to be the case because remember, it's just the inverse of the ratio, right? It's just solving for the opposite. So that's very significant when you start thinking about international trade. And that is, even if we're more productive than all the people in Mexico, if they have a comparative advantage, which they will in some product, then trade is possible. Specialization in trade is possible because they have a lower opportunity cost of producing that particular good. Now, we use graphs a lot in economics because once I have drawn the relationship as a graph, I can solve a lot of problems without doing any calculations. And that's why economists use graphs all the time. Because once I've derived what the function is, then you can answer a lot of questions without doing any calculations, which is cool. So here I'm gonna plot on the two axes the two possible outputs that Caruso could produce, and plot them according to his relative abilities. So if he produces zero coconuts, he's able to produce 8 fish. If he produces 0 fish, he's able to produce 8 coconuts. Or, as I said, any linear combination along that line. 0 and 8, and then 1 and 7, and then 2 and 6, and then 4 and 4, and then down here 7 and 1. So those are all points that are possible for him to produce. Once you've derived the function, notice that you can answer a whole bunch of questions without doing any calculations. Is it possible for him to reach that combination of coconuts and fish? This combination here.
No.
Well, think about it. He's able, if he produces this quantity of coconuts, he's able to produce simultaneously this many units of fish in addition. So any point on the interior is reachable. Any point on the interior is reachable. You know, he could. Here's four fish and 2 coconuts. They're right there. Well, he could do that in a half a day, right? Or you know, not even work the entire day. So right away, as I said, once you've drawn the maximum, and that's what that is, a maximum combined rate of production for him, any point on the interior is reachable with that 8 hours of labor. Any point on the line is not only reachable, but it is efficient because he's allocating all of his efforts in the appropriate way to get the most possible fish when he's producing a certain amount of coconuts. Or he can get the most coconuts when he's producing a certain amount of fish. Any point beyond there, any one of these points out here, are they possible? No, because they're beyond his abilities. They're beyond his abilities. So if you were doing this, you'd have pluses on all the interior points and the points on the line. You have minuses, all the points out here, as not, in fact, reachable. These other points, by the way, are the combinations that poets write about. They're also the combinations that politicians promise when they're running for office. They run for office and they say, look, if you elect me, we can have lower taxes, we can have a higher rate of growth. The great phrase during the Great Depression was a chicken in every pot, and that was the idea that if you elect me, I can make things better. But the politicians promise all the combinations, right? They say we can have low unemployment and low interest rates and high rates of growth and good education for everybody. And everything will be fair amongst all the minority groups or all the groups in society, and we'll have great relationships with everybody in the world. No. If you do more of one thing, you have to do less of something else if you have scarcity, right? If you have scarcity, you put more money into education, you got to take money from somewhere. Either raise taxes, which takes it out of your pocket, or reduce defense, which takes it out of that, or whatever the case may be. Friday, we can draw in the same graph for him in the same manner. His maximum fish output with no coconuts would be 10. His maximum coconuts with no fish would be 20, or any linear combination between the two. He could do 10 fish and 0 coconuts, or he could do 9 coconuts and what? I'm sorry, 9 fish and what? 2 coconuts, right? Because it's a 1 to 2 relationship, right? Every time you give up a fish, he's able to gain 2 coconuts. So his ratio is 1 to 1/2, or 1/2. Now, the line has a slope to it. The function has a slope to it. And in this case, number 1, the slope is negative. And that means to get more coconuts, you have to do what? Give up fish. Good. Or to have more fish, you have to give up coconuts. So a downward sloping line has a negative coefficient, because in here, it represents opportunity cost. More of one has to mean less of the other. The way to calculate slope is what's called rise over run. And you want to get that in your notes and know that is the definition. It's the change in the vertical divided by the change in the horizontal. So in this case, it would be delta F, delta means change, divided by delta C. And that gives us the sign. What's the slope for Caruso? Caruso. Good, -1, because going down 1 goes over 1. What's the slope for Friday? Excellent, excellent. -1/2. Yes, ma'am.
So a opportunity cost slope will always be negative?
And any cost will always be negative because it is negative. And that what that means is more of one has to mean less of the other, right? So either way you went, you'd have a negative sign, right? Either the numerator or the denominator. And in either case, the whole ratio is negative, right? Positive over a negative is a negative. Negative over a positive is a negative. Right. Yeah.
I was trying to picture, you said if they sold 9 fish, it would be 11, or whatever you said, coconut. How would you see that on the graph, like 9?
Well, once I know the slope is -1/2, and I also know, just looking at the numbers 10 versus 20 in the same day, that the ratio was 1 to 2. Remember, we had that in the previous slide, right? For Friday, his ratio was 1 to 2. Good. 1 fish to 2 coconuts. So knowing that, I can look at this and say it's 0 and 10, and then if he gets 1 less fish, he can move over 2, right? Because his ratio is 1 to 2. Good. So that would be 9 and 2, right? Good. And then 8 and anybody?
4.
8 and 4. Good. Or 7 and 6. Good. So you're just applying the 1 to 2 ratio as you move down that particular scale. That good question. Yeah.
Is that true to say any point below the line is equal for less than 8 hours of work?
Well, something is inefficient. They could be working 8 hours, but just not trying as hard, right? I'm assuming, by the way, for further analysis, that the two tasks are equally difficult. The two tasks are equally amount of work involved in them, and that I'm only doing that because later on I want to make another implication. But yeah, somehow it's inefficient not to be producing at the maximum. Assuming there's no other good that you could be producing with that time. So you're limited to just these two goods. Good question. So as I said, the function divides the space up between what is possible and impossible. The slope shows the relationship between the two variables, and the sign is negative, showing that in fact there is a cost involved. More coconuts has to be less fish. More fish has to be less coconuts. Now, before they specialize, think of them as being at both ends of the island. Or if you're doing international trade, think of it as there are barriers to trade. These two countries agree not to trade with each other. Or the cost of shipping between them is so great that there's no possibility of specializing in trading. Everybody with me? It's like you have two villages and there's this giant mountain between them. So it's not possible for them to exchange between them. If that's the case, Caruso's output and consumption will be the same. He's going to choose some rate of production of fish and some rate of production of coconuts, which will also be his own rate of consumption. It's the same thing with the United States. If we're thinking about wine and corn, how would you decide how much wine to produce and how much corn to produce if there were no international trade? Well, it would depend on two factors. One, the relative ability between the two goods, right? How much does it cost me of this to produce that, and vice versa? And then secondly, what are my tastes and preference? What are my personal, how much satisfaction do I get from corn or from wine? Combined with how much does it cost me in terms of wine to grow corn or corn to grow and produce wine? Which means domestically, markets, and we'll do this when we derive the demand function and the supply function, market prices determine the relative rates of production of these various goods combined with my ability to produce. And if there's no trade, then they are domestic prices. So thinking about Caruso, I've just chosen a combination. He could choose any combination. Y'all with me? He could choose 0 and 10 or 9 and 1 or whatever the case may be. I've just put one in there that says he decided, based on the fact that his ratio is 1-to-1 in opportunity cost, based on how much he likes the two goods, that he's chosen to produce and consume 4 and 4. Everybody with me? He's made the decision all on his own. It only depends on his own liking of the two goods and his own relative ability to produce the two goods. The same thing's true of Friday. And again, I just chose a possible combination. In each case, I chose to split the day in half. So Friday produces and consumes 5 fish and produces and consumes 10 coconuts. So if I look at them as a society, although right now they're separated, they can't trade, the total output of fish would be 9 fish, and the total output of coconuts would be 14 coconuts. So if they allocate their resources as we've indicated here, then that's the amount you could produce, 9 fish and 14 coconuts. But now I want to take into consideration opportunity cost and comparative advantage. And I want to reorganize production, taking that knowledge into account to try to see what I could produce if I have them specialize. If I have them specialize where they have a comparative advantage. Now, to isolate the gain, I'm going to shoot for the same output of fish, 9 fish. Who would I want to do the fishing? Caruso or Friday? Caruso, why? Right, a lower opportunity cost. Good. But I want 9 in total, right? So I would have him specialize and produce 8 fish. That's his maximum. If he does that, it's 0 coconuts. And then, because I wanted to get to 9, I'll have Friday produce 1 fish, and then I get 9 fish as the output. But now, we've taken care of Caruso. He's 8 and 0. When we look over at Friday, if he produces 1 fish, how many coconuts can he produce?
18.
Excellent, 18. Because remember, his give-up ratio is 1-to-2. And so after organizing according to comparative advantage, I now get 9 fish and 18 coconuts. Did they work any harder? No. Did they work any longer hours? No. Did I add any resources to the analysis? No. But simply by taking into account the differences in relative ability, meaning identifying comparative advantage, adjusting production according to the lowest cost resource, I get more output in that way. The same thing applies to international trade between the United States and Mexico, United States and Canada, any relationship between two countries. You're not going to have the same ratios, ability to produce, the two goods, whatever they may be. And consequently, if you specialize where you have a comparative advantage, then in fact you can produce larger amounts, and that gain can be shared by both parties. Y'all with me? As a group, they now have 4 extra coconuts. Now, go back and look look what Crusoe was doing by himself. He was getting 4 and 4. He now has 8 fish, and he doesn't have any coconuts. And we can see he likes coconuts, right? He likes to consume coconuts. So if you were Friday and you were the person who knew about comparative advantage, you would have said to him, if you specialize in fishing, you'll end up with 8 fish. I will sell you, I will buy 4 of your fish and pay you 5 coconuts. Everybody with me? He can do that because now he's got 18 coconuts, right, that he's holding on to. So because there's a gain of 4 coconuts in output, he can make Caruso better off. He can make him better off by offering 1 extra coconut to him, which is better than he had before. Everybody see it? Right? The gains from trade can be shared between the 2 parties, and in fact they have to be shared, otherwise Caruso has no incentive to do it. Everybody see that? If you don't make Caruso better off after specializing, then he has no incentive to do it. If he's no better off, he'd just say, no, I'm not going to do it. Because changing involves costs, right? Changing what you're doing involves costs of adjustment. So in that case, with that particular distribution, he'd be made better off by 1 coconut, and Friday would be made better off by 3 coconuts, because you got 4 extra ones in total. How does that apply to international trade? Well, it applies in the sense that the gains from trade have to be split between both countries. As I said, otherwise the country's not going to specialize. But the person who is a better negotiator, a person with more knowledge, for example, of the relative abilities, or a person who's a better negotiator, could end up with a larger portion of the gains from trade. Everybody see it? If I'm just a better negotiator, you don't know much, and I say to you, look, you're going to be made better off by a coconut. You say, well, cool, that's great, right? And you don't know, I'm going to be made better off by 3 coconuts. So that's the idea. The gains from trade come about because you've specialized production according to comparative advantage. And doing that, you produce a larger total amount. And the larger total then can be shared between both parties or both countries and make both countries better off as a result of that activity. Specialization means no increase in resources, not working any harder, and you get increased output in our simple example for coconuts. And as we said, it has to be shared between the 2 countries to make them both better off, or there's no reason, in fact, to do it. Now, before going on, and I'm going to talk about now multiple resources and make it a little bit more complex and interesting. But I want to talk about international trade because it's a big topic. And in the election run-up and since then, Trump has been talking about how trade is terrible. NAFTA is the worst thing that ever happened to the United States. And even Hillary Clinton was not pro-trade. She also came out and suggested that the TPP, which was an agreement among 11 nations to reduce tariffs and thereby increase the amount of international trade, was not the best deal. And if you had implemented it, it would mean there's less impediments to trade, more trade would take place, more gains would be generated in all the various countries. It's always easy to say, I could do better, right? It's always easy to say, oh, the people who negotiated that were stupid, and I can do much better than that because I'm a great negotiator, right? It's easy to say, and if you say it enough times, loud enough, some people believe it, right? I'm a great businessman. Actually, you're not, Donald. You actually didn't do that well. You went bankrupt 4 times. And anyway, other things. So trade does generate value. And it is true, however, that when we put NAFTA in place, which was lowering the tariffs between the United States, Mexico, United States, Canada, and Canada, Mexico, American firms in the Midwest, many of them, moved their assembly activities to Mexico. And the maquiladoras are the Mexican companies that exist right along the border in Tijuana and Juarez and just below the border. And a lot of new firms, new production facilities were built in those areas. And a lot of assembly work was shipped from the United States to Mexico. And so clearly people did lose their jobs in the Northeast, and what is now called the Rust Belt of Michigan and Detroit and Pennsylvania and that whole area of the country, which used to be stronger in manufacturing. Workers in the steel industry are being paid $23 an hour, well above any steel workers in the entire world. So the question you ought to raise is, or you might raise is, well, wait a minute. Clearly these people are made worse off. How can you say that trade, generates value? Well, they were made worse off. Those individuals were made worse off. But because of shifting that production down there, costs of all these products went down. They went down due to competition between companies, but they were able to lower their costs of production by moving to Mexico. And as a result, competition in the marketplace led to lower prices in the United States. Years ago in the South, we produced a lot of cotton, and then we produced a lot of cloth in the South. There were mills all over the South that would produce cloth and so forth, like t-shirt cloth. And gradually, South Korea began to specialize in production of fabric until they were less expensive than the United States. They could produce it more cheaply than the United States. Did it cause a loss of jobs in the United States? Yeah. But these kinds of job losses are always gradual, unless it's the government making a big change in something. They're always gradual. When you hear that the GE laid off 2,000 people, what is the visual image you have? Anybody? What do you visualize?
2,000 people are unemployed.
Good, and they're working now, and then they won't be working,
Yeah.
and they're handed pink slips.
Yeah.
That's the way it sounds, right? GE's laying off 2,000 people. Well, it turns out that number one, GE is not laying off 2,000 people right now at this moment. Number one, they will offer what's called a golden handshake to management, which the university did at one time to reduce the size of the tenured faculty because part-timers are cheaper. And so some of them will voluntarily retire because they're going to get a bonus of money for, in fact, doing it. Secondly, and particularly when I talk about the cotton throughout the South, and even the changes with respect to NAFTA, what happened in most firms was that I simply didn't replace workers that retired. I simply didn't buy another worker when this worker retires. Everybody see it? And my employment goes down, it does go down, but I didn't fire anybody. I didn't give them a pink slip. I simply did not hire when, in fact, my existing employees were leaving. So a lot of that adjustment is not what you visualize. It's not that suddenly these people are out of work. It's usually a gradual thing, even in manufacturing in the Midwest. Also, by the way, if you compare production in Mexico versus production in the United States, the Mexican workers were earning about $6 an hour. The guys up in Michigan were earning like $18, $21 an hour. So you would say, wow, I mean, obviously they're going to move to Mexico. But look at the other aspects of changing the geographic location of production. The roads in Mexico are horrible. They're horrible. They're all just bumpy and they have potholes in them and all kinds of stuff like that. The laws in Mexico are not enforced the way they are in the United States. Hijacking is very common in Mexico, as is holding people for ransom, right? What's the word I want? Capturing people and then, what?
Kidnapping?
Yeah, kidnapping people and then holding them for ransom, which is really prevalent in the Middle East. But anyway, these companies who moved to India to do their customer service work, and people who moved to Mexico found over time that in fact it may not be cheaper for them, because if you lose a whole truckload of washers, right, a whole truckload of washers, that's a big loss, right, because it's gone and the truck's gone too. And then other stuff breaks as it goes across the roads, and then you have difficulty in managing the people, Quality control becomes much, much more difficult, especially if you have language differentials and cultural differentials. The firms that shipped all of their customer service lines to India found that it was very difficult, and American customers were very upset because they knew this guy was, hi, I am Harvey in Los Angeles. No, you're not. No, you're Jahid in Delhi or something. Right? Good. So a lot of those jobs came back. And in fact, in that area, it's interesting, they discovered that in the Midwest, the farmers are relatively intelligent people because farming today is relatively advanced. But in the wintertime, they don't work because they can't, right? You raise the crops and then it's winter and you stay inside and, fix the nets and do other stuff. So particularly the women, the farmers' wives in the Midwest have become a major source of customer service. Because number one, they're available, right? And they can do it from home, so they don't have to go somewhere. And they can do it well, and they speak the language clearly and so forth. So a lot of these things get changed backward in that particular way. Second point is this: as Mexican workers earn more money, what are they going to do with the money? What do you do with money? Buy stuff. And a lot of the stuff they bought is stuff that was produced in the United States. In the Southwest, mattresses are normally produced local to where they are consumed because the cost of transportation is very high. Shipping and move. If you ever tried to move a mattress, you know what I'm talking about. But you had a big increase in the demand for mattresses made in San Diego and the Southwest. You had a big increase in demand for appliances, such as washers and dryers and small electric appliances, which led to increased jobs in that area of the country. So trade always generates more benefits than it does losses. Trade always generates a net benefit because there's more being produced. The problem is that in thinking about it, I can see where the jobs are lost, right? That's real easy to see. When jobs are lost, they announced, they're doing this and laying people off. Carrier announced they were going to move a plant to Mexico and lay off 900 people or something like that. But you don't see the lower prices that all of us get as a result of the trade. The benefits are spread across the entire group of consuming public. But you don't know that. You don't know that the T-shirt is $3 cheaper than it would have been if you had not had that specialization. It's Melody? Yeah.
iPhones would cost $2,000 if they were made.
I'm sorry.
iPhones would cost $2,000 if they were made.
In the United States? Yeah.
So it benefits consumers.
Absolutely.
China has a growing middle class that we're selling that product.
Absolutely. And although they are going to move some production back to the United States, there's some aspects of that production that they've had. Foxmore, I think, is the name of the company that runs all these jobs in China. And so they are going to move some production back to the United States. And Trump has taken a lot of credit for moving jobs back to the United States. When you actually look into the facts, most of those jobs were coming back anyway. When Carrier decided to move to Mexico, that plan had been made, like these kinds of plans are made 2 and 3 years ahead of time. You guys with me? These kinds of big changes are thought about and negotiated with those countries and get tax breaks for doing it. All this kind of stuff takes a long time. So the fact that we saved 800 jobs was a decision Carrier had already made. But it sounds great for Carrier to say, well, we're going to help Donald and we're going to save these jobs for the public. I think I told you this in the opening lecture. 70% of what you hear that is negative is false, particularly that's negative. 70% of it is just not true. Either they don't know that it's not true, so it's an honest mistake, or they know it's not true, but they want to get across some position and make you think certain kinds of things. So the world is a lot less awful than it sounds. I watched Florida, just a tremendous tragedy, and it went on and on. Miami had gale force winds for like 12 straight hours above 70 miles an hour. Just terrible things. But if you listen to all of the prognosis that the pundits were saying, it all turned out to be less than what they claimed. It was like there's going to be a tidal surge on the southwest coast of 8 to 15 feet. 15 feet of water is going to come surging into that area along the coast. No, it was like 6 feet. And it doesn't come in like a wave. It comes in and it goes up relatively quickly, but it doesn't come in like a giant wave, etc. Good. Okay, so that's the background on trade. And as I said, there's another thing that governments could think about doing, and that is have the gainers compensate the losers. That is, the people who are made better off take some of that benefit and then transfer it to the people who are made worse off. And that's called the Hicks-Caldor level of a Pareto optimal move means the gain's bigger than the loss. A Hicks-Caldor move means that the gainers have compensated the losers. And you can do that with tax policy, for example, at the federal level. You can do it in other ways. The government's not very good at it, but you can try and do it. Years ago, when we had this decline in jobs in manufacturing in the Northeast, there was a big oil boom in the South, and there was a big demand for riggers. And riggers are mechanical people that have jobs like manufacturing. You have to learn how to do things, and then you go out and do them and change things and change gears and all kinds of stuff. So the government decided that they were going to help out these people, and they put in place an educational policy, a 6-month program for these people who had lost their jobs in the North. It took them about a year to get it set up. It takes time to get things organized and hire people to teach them and so forth. And so they went through the 6-month program, and the government had agreed to pay their moving expenses to move down to Oklahoma and Texas to take these other jobs. So it sounded really good. It turns out, because it was 18 months or closer to 2 years, by that time the oil boom was over. So there were no new jobs in rigging. In fact, there were losses of jobs. And so these people were not made better off by the program because it moved too slowly. So all of this stuff is complex, but we know that trade generates benefits for both parties, and so that's what economics tells us. The example is so simple, right? The Caruso-Friday example shows you exactly what we're talking about, that there is an increase in goods to be shared amongst the various individuals. Now, I want to extend our analysis beyond two inputs to multiple inputs, and then draw a production possibilities function, and then see what implications we can derive from it, similar to the one I drew for Caruso, the one I drew for Friday. So here my assumption is we have fixed resources, just as we did with Caruso and Friday. Here we have 10 acres of land, 10 acres of land. And they're organized in rows. So row 1 is 1 acre. Row 2 is 1 acre. Everybody with me? 10 rows, 1 acre each are our resources. We're going to adopt the same level of technology as we compare different possible organizations of output. And so the way we describe that assumption is we're going to use fixed technology. It just means technology is not changing while we evaluate these other things. Third, we're going to have the numbers reflect that these rows vary in their relative ability to produce the two goods, because that's our assumption about what is true about resources in production. So here are our rows. We have 10 rows. We have 2 possible goods they could produce, corn or wheat. To make the analysis easier, I have stated that no matter where you plant corn, you will get 10 bushels. Everybody with me? Any row will yield 10 bushels of corn. Corn is impervious to the amount of water in the soil, and wheat is affected by the amount of water in the soil. And so theoretically there's a stream running down past the 10th row, so that land is more moist, so wheat grows better in that particular area. So as I said, to make it simple, no matter where you plant corn, you get 10 bushels. If you plant wheat in row 1, you get 10 bushels, same amount as you did with corn. But as you move to row 2, 3, 4, on up to 10, the wheat output is going up because you're getting more units of wheat produced per row because the soil is more moist in that particular way. So as we did with Caruso and Friday, I want to calculate the cost per unit in terms of opportunity cost. I want to calculate the cost of each corn in terms of wheat given up, or the cost of each wheat in terms of corn given up. Oops. So the next row is simply solving for one to one. Everybody with me, right? If 10 corn equals 10 wheat, then each corn equals 1 wheat, and each corn costs 1 wheat, and each wheat costs 1 corn. If you go to row 2, each of those corns now cost me 1.2 units of wheat, because 10, 12, solve for, divide by 10, you get 1 equals 1.2. So the opportunity cost of growing corn in row 2 would be 1.2 bushels of wheat per bushel. And then it goes to 1.4 because it's going 10 to 14, then 10 to 16. Then when you get to row 6, it's 10 to 20. So each corn is costing you 2 units of wheat. And then when you get all the way out to row 10, each corn is costing you 2.8 units of wheat. So opportunity cost is solving that ratio 1 to 1. The cost of 1 wheat in terms of corn is the inverse of that number. So you just solve in the opposite way. In row 1 it's 1, in row 2 it's 12 equals 10, divide through, and meaning each wheat costs you 0.83 units of corn. As you move over, the cost of 1 wheat is going down because you're getting more wheat per row as you move in that particular direction. So the amount of corn given up as a ratio is in fact smaller. So let me go back to this. If you were planted in all corn, so the all 10 rows are planted in corn, how much are you getting as output? 10 rows, 10 bushels each, 100 bushels, right? It's all planted in corn. If you wanted to begin planting wheat, what row would you plant first? Row 10, because that's the most wheat you can get for any of the rows. Good. So in doing that, I would give up 10 units of corn, and I would gain 28 units of wheat. Everybody see it? That's what my output would be at that particular point. If you wanted to plant more wheat, what row would you go to next? Row 9, and you see it now, or 9, 8, 7, 6, because in each case you'd be maximizing the amount of additional wheat that's being produced. So if I were to draw these combinations of output, I'm starting at 100 units of corn, and I reduce that by 10 to 90, and I gain 28 bushels. So that's that upper flattest unit. In the next row, I lose 10, but I only gain 26. In the next row, I lose 10, but only gain 24. What's happening to the slope? It's becoming steeper, right? Because the lowest cost was moving from all corn to row 10 in wheat, and then row 20, and then row 9, row 8, row 7. When you get down here to row 1, it's a 1 to 1 ratio, right? Because row 1 was 10 to 10. So here, each corn cost me one additional unit of wheat. So I've derived the production possibilities boundary for this set of 10 resources, and I've organized the production in the most efficient manner possible. I've always chosen the lowest opportunity cost to increase the production of wheat, and you can see that the way I've organized my production. Yeah.
Both rows are the actual production, not the row, right? Like 50 is the production.
No, on the graph you're looking at total output, the total amount being produced. So if it's all corn, there'd be 0 wheat, and we'd be at 100, right? Good. If I switch row 10 to wheat, I'd come down 10 in corn and come over 28 in wheat, right? Good. So that point represents 1 through 9 in corn and row 10 in wheat. This one here represents 9 rows of wheat and 1 row of corn. That's that point right there. And then that last one, I give up 10 corn and get 10 wheat. That's row 1. Good, good. So it's different combinations of the resources, and then what is my output combination as a result of that particular level of choice. Now, once again, the curve is downward sloping, which means what's true about the slope? Negative, and that represents cost, right? More wheat means less corn. More corn means less wheat. So we already know that. But notice that here, it is not a straight line. Here, the curve is curved. And the way to describe that is it is concave with respect to the origin. The way to describe that shape of the curve is to stand at the origin and look at what you're looking at is like the inside of a contact lens or an IMAX theater. Isn't that the one that has the thing goes around like that? Concave means that it's further in the center than it is on the edges. It bends away from me. Convex means the opposite. Convex would mean what? That it's the outside of a contact lens. So it bends away from me in that way. The curve is concave, which represents increasing marginal cost of production. Because I chose the combinations that I did to maximize the joint output, notice that it's flat, but then it's becoming steeper and steeper and steeper. And that's what gives it this particular shape. And that reflects the fact that as I try and produce more wheat, the cost is going up. The cost is increasing as I produce more wheat. And the same thing's true in the opposite direction. If I start with all wheat, the first place I would plant corn would be in row 1 because I'm only giving up 10 bushels of wheat. If I want more corn, I can go up 10, but now I'm going to lose 12, right? Because that's what the ratio was in row 2. And so it holds true in both ways. So the shape of the curve now is an additional characteristic of the function. Downward sloping means it divides the space, like we talked about before. All these lower points are possible. All the points on the function are efficient. You've maximized the amount of corn for the amount of wheat you're producing. All the points beyond it are not possible with the current resources, the current technology, the assumptions that we made when we drew that particular function. Somebody raise their hand. No? Okay. Curve divides the space. We talked about that. Points beyond are not possible. Slope is rise over 1. Here, it's negative, reflecting cost. And now the shape we've added reflects another characteristic of the function. And that is, as I try to produce more wheat, the marginal cost is going up. Or as I try to produce more corn, the marginal cost is going up as I adjust using the best alternative resources. So here's a production possibility boundary. And now what we do with graphs is we say, how would the function change if I change an assumption? How would the function change if I change one of the assumptions? The first would be, suppose I add 2 more rows to the 10 rows. So I'm increasing the amount of resources available. They could be used for what? These 2 extra rows could be used for either corn or wheat. Everybody see it, right? Good. How would you describe, how would the function change? Visually, how would the function change? Raise your hand. Yes, sir. In both directions. Excellent. Good. Yeah, you just see it shift outward in that case. Now again, I've shown what looks like a parallel shift. That's not necessary. It could be that you get a lot more corn and a little bit more wheat, so it doesn't have to be parallel. But the function would shift outward, showing that with additional resources, I can produce more corn and wheat. So adding resources shifts the curve out. How would the curve change if there is a change in technology that allows me to grow wheat less expensively and it doesn't affect the amount of corn? I just plant wheat sooner, and everything else is the same. I plant wheat sooner, and I get more wheat output. But it doesn't. But my change in technology does not affect corn. How would it shift?
Would the graphs extend further along the x-axis?
Good. This point will move outward. Good. What about the intercept up there? No change because it doesn't affect corn. Excellent. Very good. So the curve would shift in this way. It would shift to show larger amounts of wheat for each amount of corn as a result of that. Now, if you ask the farmer, without any graphs or anything else, if you ask the farmer if you can produce more wheat from the same land simply by changing the technique of production, what happens to the cost of producing wheat? He's got a new technology, gets more wheat per acre, doesn't work any harder. What's happened to cost? It's gone down, right? And you can see that by the changing slope of the new curve, right? Good. And anybody knows that, right? He doesn't have to be an economist to know that. Thinking like an economist, if this technology increases the amount of wheat with no change in the amount of corn, what is the effect on the cost of growing corn? How do you measure cost? What you've given up, right? Opportunity cost, good. If more wheat is now being grown per acre, what is true about the amount of wheat you're giving up for each unit of corn? It's larger, good. And so this technological change, while it lowers the cost of growing wheat, which is obvious, raises the cost of growing corn. Everybody see it? Because it's an opportunity cost, right? If you plant corn, you're giving up wheat. If you can now have more wheat, then you're giving up more. Years ago, the environmentalists decided to require, well, actually the farmers, decided to require the major oil companies to produce gasoline in the summer and use 10% of it as being produced from a crop. And it's called ethanol, and it's a form of gasoline. And you can process the corn and ferment it in certain ways, and then you end up with gasoline. Don't ask me how. It just does. Good. It's fascinating. You can actually produce gasoline from any biological product. You can do it from wheat, straw, anything else. Who's the singer that drives around on a bus? What? Willie Nelson. Very good. See, I knew that hint would get it, right? Willie Nelson drives around on biofuel in his bus, and it's not made from corn. It's made from something else, straw or wheat or something else. But what's fascinating is when they passed the legislation, there are all these representatives in the red states, which are the interior states, which is where agriculture is grown, and they required that the ethanol be made from corn. They required it has to be made from corn. Who required it? The politicians whose states grow corn, right? They did it to make their people better off. What happened to the price of corn? Went up dramatically because now all these oil companies had to go out and build refineries and then buy all this corn to make it into gasoline. So the amount that was being purchased was now much bigger because all these new people were buying up the corn, and so corn prices actually tripled after that passed because it was that big of a bonus. And then the farmers just planted more and more corn, right? Because now the price is 3 times what it was before. When that happened, how did that affect the price of other goods, other agricultural products?
Down. It was up because they instead of those products they were growing corn.
Good. When corn got so much more pricey, farmers moved their production of other goods out and put corn in instead. So they produced less wheat and they produced less of the other agricultural products. And that caused those prices to go up because there was less of it being produced for the same amount of demand to purchase it. So there are these ripple effects that take place. When you change one thing, people adjust, and then there are these ripple effects on other products. And we'll see that when we get into the analysis of the markets and demand and supply. Good. So changing the assumptions will shift the curve. An increase in resources shifts it outward. An increase in technology of wheat does what we indicated, lowers the cost of wheat, raises the cost of producing corn.